in the VM Development Lab in Endicott, New York. And we're here to talk about ZVM 6.4 preparation and use. So if you were, how many of you were in Bill's platform update session in the last time slot? Okay. So you'll see some of the same charts. They're not all the same, but to set the context, actually I'm going to kind of start out with where he left off, and then we're going to talk about some of the same items he talked about, but I'm going to take a different perspective, more about what you need to think about if you want to use these functions, why you might want to think about using some of these new things that we put in ZVM 6.4, and then how to do that, or where to go find out how to do that. Okay. So we'll start with release notes, which is kind of the status of the releases that Bill also covered. Things you need to look at or do on your current system before you migrate, things to do as you migrate, and then once you get the system up and running, things you might want to change, look at, take measurements to compare, see if you're getting benefit out of some of the new features you're using. So release status, so like I said, some of the same charts. So 6.4 became available in November of this year. We did an architecture level set, requires at least a Z196 or Z114. We did not announce the end of service date as we have been doing typically in past releases, because we don't really know when that's going to be right now. So, but some other key things that have been announced recently is end of service for the prior releases. So end of service for 5.4 will be the end of this year, December of this year. We've been holding on to support for that, waiting for for as long as the Z9, because it's the last VM release that'll run on the Z9 processor. But we put the stake in the ground now, so that will go out of service at the end of this year. ZVM 6.2 will go out of service in June of this year, and 6.3 will end service at the end of this year as well. So at the end of 2017, the only release of ZVM that will remain in support will be 6.4. Okay. 6.4 became available in November of last year, November of 2016. As Bill talked about in more detail than I will, release born from customer feedback. So from a lot of different sources, help prioritize things we were doing, our list of things to do versus things that customers needed. So a lot of that was fed back in and considered in how we prioritize things. Not that we don't do that in the past, but a lot of times, say we have a new processor coming out, the requirement to support that overrides some other things we'd like to do. So in this case, we had some time and got some things done more for your benefit. And the two key topics or themes of the release, if you would, enhanced technology for scaling and cost of ownership, increased memory, things like that, efficiencies with the increased memory sizes, more disk volumes, things like that, and system program management capabilities. And Bill talked about some of that, and I'll show you some examples of some of that. In some cases, it's the information is there, but we don't have an easy way to look at it. We know it's there. You guys have it, but why won't you show it to us? In some cases, it's a simple, SMOP, simple matter of programming. I'll add a T and a D, simple matter of programming, testing, and documenting. But the thing is, somebody needs to do that, and we've done some of that in 6.4. And I mentioned the architecture level set. So if you're going to go to 6.4, you have to be at least on a Z196. Supported hardware, from most recent to oldest, the Z13 family. Again, as Bill said, if I say Z13, it means any or all of Z13, Z13S, or the Linux 1 processors, the EC12s, and the Z196. So any of those you can run ZVM 6.4 on. And no more tapes for install, so you can do an electronic install, DVD install, but no more tapes. So fewer and fewer people are using tapes. I don't know that they're very common anymore, but no more tapes for install. So some of the things, and I showed you those themes. So these are some of the examples of the items that kind of apply to those themes. This is just some things we're highlighting. So for the scalability and TCO HyperPav, the increased memory support to 2 terabytes, a large page support for guests, transaction execution, flash system support for system volumes. For systems programmer, Bill talked about the CMS pipelines enhancements. I'm not really going to talk about those in this presentation, but it will help you, significant enhancements to the pipelines functions that are available, upgrade in place, the environment variables, query CP service, where you can get a list of service, or you can check all the service that's applied to my system, or is this particular PTF or APAR applied to my system, so you can get information about that. And the disk query enhancements for SCSI and ECKD, and et cetera in both categories. So we'll talk about some of those other things as well. Upgrade in place was introduced in ZVM 6.3 to make it easier to upgrade from 6.2, primarily with SSI to 6.3. We didn't want you to have to, if you're running an SSI cluster, have to shut your whole cluster down to do a release migration. Kind of defeats the purpose of having a cluster in the first place. But some tools and procedures to make it easier to upgrade from release to release. So we've enhanced that now for 6.4. So now you can use upgrade in place to migrate from either ZVM 6.2 or 6.3 to 6.4. Again, it's especially handy in an SSI environment, but a lot of people have found good use for that in non-SSI environments as well. So the processes, you can apply mods both from vendors, and if you have your own, any modifications, gives you the ability to back out changes as well. There's service required in order to use upgrade in place. There's service required on your current or prior to 6.4 release of VM in order to do the upgrade to 6.4. So you want to check out what's required there. And the install guide has the information, has all the detail on the prerequisites, service required, and of course the procedures of how to go about doing upgrade in place. If you'd like to try that out, Richard Lewis has a lab tomorrow, ZVM installation, migration, or upgrade. It's a 3-part lab. I think it starts tomorrow morning. So an upgrade in place is one of the options, one of the labs that you can do as part of that lab. So if you want to try this out. Richard also has a session on this. I think it's Wednesday morning. So you might want to look for that if you want to hear more details about upgrade in place. If you're doing a fresh install, there's some things to be aware of as well. You can now use mod 27s, 3390 mod 27s for install. For components, the default is SFS directories instead of mini disks. You can still use mini disks. If you don't use SFS or whatever, you can still use mini disks. But the default for components like DERM8 and some of the license programs is SFS. The components will have different names. And the intention of that is to make it easier for expansion. Instead of having to allocate a new disk as disk requirements grow down the road, it's easier to do that with your using SFS directories. If you're using full pack mini disks, you're installing to full pack mini disks. Typically, you define the size of that mini disk as N-1 cylinder, so the size of the volume minus 1 cylinder. For 6.4, if you're using mod 3s or mod 9s, actually mod 27s also, you now have to specify the entire size of the mini disk, so no more N-1. We might be able to change back to mod 9s in the future, if we recut the install DVD, we're looking at that now if we can change that back. But be aware of that. So the size, if you have some automation or tools that you use that specify the size as n-1, you probably have to go in and change those. Or you're just used to doing it that way. You'll have to go in, do it a little differently. Expanded storage, when 6.3 was released, we had a statement of direction saying we were going to end support, no longer support expanded storage, and that is now true with ZVM 6.4. So no more use of expanded storage by ZVM, starting with 6.4. For both 6.4 or if you're running 6.3, you should convert anything that expanded storage you had defined, the system won't use it. Well, in 6.3 it will use it if it's there, in 6.4 it will not. So you want to convert that to real storage or central storage. So you can use it all. A VM system can use it all. In 6.3 we did a bunch of memory management enhancements for scalability, and that kind of made the benefit we were getting from using expanded storage made that obsolete based on the changes that were made, negated the benefit of using expanded storage. Okay, scheduler. So Bill mentioned briefly some changes to the scheduler, eligible lists, things like that. So talk about that a little bit. So scheduler 101, most of your virtual machines sit in a dormant list until they have work to do. Then they have something to do, and they get moved either very seldom into the eligible list anymore, but a check is done. Eligible list, and then into the dispatch list. And so the eligible list is there to make sure we don't overload the dispatch list, we don't overload the system or cause thrashing. If there's resources that a virtual machine needs to do whatever it's trying to do, and they're not available, we were, prior to 6.4, putting those users in an eligible list until everything became available and there was space, and then move them to the dispatch list. The virtual machine or user, I'll say those interchangeably, would run its minor time slice and loop back into the dispatch list until the minor time, with these minor time slices until its larger time slice or its elapsed time slice expired, and then we'll go through the cycle again. If it had more work to do, it would want to be dispatched again. If not, it would go wait in the dormant list. So, and then you used to sort of manage to make sure not too many things got put into the dispatch list from the eligible list. Overuse of resources. You set the SRM, a load buff and store buff. So that was kind of managed how much work was put into the dispatch list at any point in time. Yeah, I just hit the wrong button. And we're back. Not where we were, though. There we go. There we go. Okay. All right. That was my bad. I should tape that button so I don't. So no longer in ZVM 6.4, we no longer use the eligible list. The eligible list is still there. It's still defined. The construct is still there. Information about it will show up in some command outputs, performance toolkit reports, things like that. But it's not being used. So all that should show no use in the eligible list. So no longer use it. In a lot of cases, we're finding as other things have scaled, we're making the wrong decisions about which virtual machines to put in the eligible list, how long they stayed there, things like that. So it's more efficient, and again, it's more efficient that we stopped using it. So you no longer have to tune that with the set SRM commands, but you do need to make sure you have enough resources to avoid thrashing, to avoid trying to do too much at one time. So you want to make sure you have enough memory, enough processor power, things like that. And the other thing was, very few, if any, systems anymore were actually forming the eligible list. We're finding that the eligible list really wasn't needed anymore in most cases. So one thing you might want to do is check on your current system to see if your eligible list, if you are forming an eligible list on your system, which you can get from Performance Toolkit. We'll show you that information. Contact us. Anybody who's here, or contact a support center, and we'll get the right people to look at it, to look at your information and see maybe why that's going on. Because if you are forming eligible lists with the in 6.4, that could cause an issue. So it's something to check. Not something I would really worry about, but something to check before you move on to 6.4. Another thing to look at is the quick disp option. Quick disp is it's been there forever. It's been in VM forever. It's an option that you put in a directory for certain virtual machines that cause them to always bypass the eligible list. Make sure critical virtual machines, so some of your service machines, your networking machines, they would always be run whenever they had something to do. So you're shipping something over the network, you want to get that out, or get information in, things like that. So some of your directory machines, things like that, would have quick disp set. So that would cause those virtual machines to always bypass the eligible list. So even though we're not using the eligible list, if you have quick disp set for any of your virtual machines, recommend you leave that set, leave it turned on. It's just easier. It's one less thing you have to do. Having it on doesn't cause anything. There are other benefits to quick disp besides just bypassing the eligible list. And then also, if you decide to back off, or say you're running in an SSI cluster with mixed 6.4 and older systems, and you log that machine onto one of the older release systems, the quick disp, you'll still get those advantages. So if you have it set, leave it set. So in addition to the eligible list, there was some issues with how the scheduler distributed surplus shares of processor power. Okay, so that's been fixed in ZVM 6.4. It may cause some. There's a chance you could see some different behaviors because of that, and I'll take you through an example. But the surplus share is distributed more equitably among the virtual machines. The one key thing that's different is normalizing the shares, the surplus shares. Now, in 6.3 and before, the normalization was considered virtual machines that were in the dispatch and eligible lists. And now in 6.4, it takes into account all the virtual machines that are logged onto your system. So even virtual machines that are in your dormant list are considered when the surplus share is distributed. So you may see some subtle differences there. So kind of an example. So say we have these 4 Linux guests running. For the sake of this example, they're all in the dispatch and or eligible lists. So the relative shares add up. The total is 600 shares among these four virtual machines. So relative shares, so they're divided accordingly. If you do the math, the 200 get twice as much essentially as the 100. But what happens if one of these guests, let's say Linux 4, really only needs or wants to use 3% of the processor power? So now we have 30% to do something with. Somebody else could use it if they need it, right? So these 2 columns, this is the original definition. So the shares and the original normalized percentages. So let's go over here to the right. So the problem scenario, and prior to 6.4, this is how the surplus would be distributed in this case. So all of the excess, all of the 30% excess would go to the other virtual machine or machines with the highest relative shares. So in this case, Linux 3 would get a 30% boost, and the other guests would stay with the same share, the same power entitlement that they had before. Okay. Now with 6.4, it's distributed proportionally based on the relative share. So we had 30%, so we got 15% additional here and 7.5% each here. So the total of 30% was distributed proportionally among the other virtual machines. So where you might see a difference is this was wrong, but maybe that guest was taking advantage of all of that extra power that it was given, and now you're taking some away. Now with 6.4, it's going to lose some of that, so you might see it behave different. So it'll be subtle. You're going to have to look at your performance measurements and things, but if you see some subtle changes in guest behavior, this is something you might want to look at. Yeah. Well, no, because you're setting the share relative. This is, it's using less than you're allowing it to use. Okay, so it's using less, so the system is going to redistribute. It's not a setting that you can change. You can probably tune it and with the shares, but it's not a setting you change. But because Linux 4 is not using all he has, it's going to get distributed by the system, the algorithms and the scheduler automatically. It's all under the covers. But this could result in a change. You might see a little different behavior if it was kind of reliant. It wasn't supposed to have it, but it's come to rely on getting that extra boost. Yeah.
I think one of the questions might be too is how many CPUs did you have behind those Linux guests?
Well, in this case, they were one ways. I'm sorry, I glossed over that, but yeah, that all factors in. This is meant to be a simple illustration of what's changed, but so they were one way, so everything's equitable that way as well. Yeah, I didn't say it. I glossed over it, but okay. So a little bit more on the normalization. So in 6.3 and earlier, as I mentioned, the share values were computed for virtual machines that were only virtual machines that were in the dispatch ineligible list. And, well, you see the details here. If the absolute shares was greater than 99, it was prorated to 99%. So there was always some share available for the relative shares. The relative shares, after the absolute shares are distributed, they were normalized based on the virtual machines that were in the dispatch and eligible lists. It says DIS, but it's dispatch ineligible. It's just to make it readable, we shorten the name. So something you want to watch when you go to 6.4, if you have a lot of users, a lot of virtual machines, depending on how the shares are distributed, a lot of virtual machines in the dormant list that aren't doing anything, that could impact the amount of work getting done. So if the sum of your relative shares is much greater than the shares that are of the virtual machines that are in your dispatch list, you might want to look at how those are allocated, how that's distributed. So again, this is some subtle things that could change the behavior based on those algorithm changes. It's meant to improve, but just be aware of that. Security changes. Alan's going to talk a lot more about security later in the week. But just to highlight a couple things, the SSL server, the default TLS is now 1.2. 1.0 is disabled. Passwords on commands defaults to no in the system config file. On a feature statement, the default had previously been yes. So these are just things to make it harder to attack, right? And the logon error message has been changed. So it used to be you typed in a user ID and if you typed in the wrong password, it would say the password's bad. But that kind of tells you the user ID was okay, because if the user ID was bad, it would tell you right off the bat the user ID was bad. So now if you type in a wrong password, it kind of says, this is typical like you log into a website. It doesn't tell you which one is wrong. It just tells you, your credentials aren't up to snuff. They're not right. So this kind of obfuscates the what's really wrong with your logon information, I guess. TCP/IP, if you're using IP Wizard utility, there's a problem. So this is just to make you aware of the problem. If you do a fresh install of 6.4 and you want to run IP Wizard, there's a problem. It would crash because it requires a TCP/IP data file and that hasn't been created yet, because that's one of the things that gets done as part of this process. So there's a web page that has information about this problem, how to get around it. Basically, you create a TCP/IP data file or copy one before you run IP Wizard. And there's also an APAR in the works to correct it. And all the details for that are on this web page. So if you're going to do a fresh install and you use IP Wizard, be aware of this and go check out that information. Okay, flash systems you can now use flash systems for system volumes, for CP volumes, without a SAN volume controller. So you can use those directly, and you define those with the E device, either statement or command. And there's a new flash attribute that you can define for the flash devices. Okay, so you no longer need the SVC controller to use flash. Okay, so Bill talked about some about the query information, and this is an example of the information that we keep in the system that's there, but you didn't have a good way to get at it, and we didn't have a way to show it to you. So this is an example. So we've enhanced some queries, and the intention was to enhance queries for SCSI devices and FCP. But in the process, we found that it was pretty easy to provide some of these enhancements for ECKD as well. So here's an example. This is the first example. So query, there's a new details operand on the query edev and query DASI commands. This example shows you the output for query for an edev details, and it adds the LUN serial number. And for query DASI, I don't have an example, but it adds the serial number as well for the ECKD device. So you can get that information. On query eDevice, we've added an inquiry option, so you can get the standard inquiry page data and the vital product data page. This is the raw hex, and I'll show you the examples with the utility that'll format that. So if you like reading hex, this is great, but we make it more readable for you as well. This is the default data for the IBM devices. Different vendors might have different data in these devices, so it can be customized, or it might look different depending on whose devices you're using. But you have the ability to get that information now. And on Query DASI, characteristics option for ECKD, you can get the read device characteristics and the configuration data. Again, the hex data. That's not always fun to read, but you can see it there as well. So IO Explorer, Bill mentioned this. This is a utility, a new utility. It's a RexExec on the utilities disk. If you look in the CP commands book, it's in the utilities section. It'll format the output from those query commands. So instead of looking at that hex stuff, it will actually format the output. So for FCP, this is an example of what it would look like, tell you what the system is, who the vendor is, some other information, the serial number, the LUN, LUN number, the size of the device, things like that. So it just makes it more readable, easier to decipher than the hex. If you like reading the hex, though, you can just stick with that. For FICON, you can use iExplore for FICON as well. You get more extensive out. There's more to tell you about, but device talks about the device information, control unit, some additional stuff, the vendor, interrupt timer, HyperPav enabled. So just information about the type of device, the capacity, number of cylinders, number of sectors, things like that. So the capacity, size of device, what type of device, who made it, things like that. So you can get a lot of, in that hex data, this kind of breaks it all down for you. It's much more readable. So again, this is a Rex exec. If you go out to the utilities list, the source is out there, so you can modify this, you can customize it. If vendors can customize it, if they have devices that have different information, they can update it as well. But you can go out there and experiment with it. But the bottom line is it formats that data for you. It gives you a nicer view of that information. So these are like those things to make your system programmer tasks easier. You have all this extra time because you get all this stuff. We're putting all this stuff out for you now. So Explore FCP command allows you to test your FCP subchannels and ports, WWPM ports. Basically, it says light up the fabric. So when you do a start, you create a list of the subchannels and ports that you want to test. Then when you do a start, it will activate those subchannels and ports, and give you feedback if there's any issues. You can take things out of the list and stop. Of course, stop as well. So the opposite of those. Query will display the subchannels that you have in your list, as well as the activation status. So did I do a start? Have I activated everything? Have I stopped it? So you can do a query and it will show you that. So that's a way to validate your paths, your channel paths, and see if they're defined correctly. Performance Toolkit. So Performance Toolkit now runs in a ZCMS machine. By now, I mean on 6.4. ZCMS virtual machine allows the toolkit code to take advantage of additional memory and the Z architecture instructions, which a lot of them are more efficient, give it more capability, more power to process the information. So make sure if you have virtual machines that use Performance Toolkit, make sure they can run in ZCMS. XC mode virtual machines are not compatible with ZCMS. ZCMS doesn't exploit VM data spaces, so just be aware of that. Bottom line, just make sure they, try them in ZCMS and make sure they run, and you'll be okay. Bill mentioned the increase in memory support from 1 terabyte to 2 terabytes, real memory. So real memory to 2 terabytes. Virtual machine limit remains at 1 terabyte. We haven't been made aware or have seen any need to increase it, at least not immediately. So that remains at 1 terabyte. No matter what your memory, as the memory sizes get bigger, the requirements for dump space and page space also increase. So you want to make sure, in any case, you want to make sure you have enough. But if you're going to increase your real memory, especially when you get up to these sizes, you want to make sure you have sufficient paging space and sufficient dump space. And even if you're not increasing your memory, if you're going to do a release upgrade, it's kind of a good time to check on that and make sure you have enough space defined for however much memory you're using to keep things running efficiently. Okay. And the planning guide, CP Planning and Admin, has information about how to calculate that and how to figure out how much space you need, and recommendations for that. Excuse me. Guest large page, Bill touched on this also. So the ability for guests to use large pages, 1 megabyte pages. So VM still uses 4K pages. So the guests can use a 1 megabyte page, but in the hypervisor, that's all still managed in 4K pages. It lets the guests run more efficiently, reduces the memory requirements because the page table, for the same amount of memory, you have smaller and fewer constructs to manage those memory pages. So it lets the guests run more efficiently. If you're going to want to use this in Linux, you want to have a kernel that has large page exploitation built in, which is the default, but you want to make sure that's there. Add the huge pages kernel parameter with the number of pages you want allocated, and you can use the syscontrol variable as well. So for guests, 1 megabyte pages for guests still managed as 4K pages in ZVM, in the host. So keep slot. So when VM reads pages in a guest page from disk, reads it into memory, we keep the slot. And by that, we mean that page's data stays in that location on disk, and we keep that associated. So we know that guest page goes to that slot on disk. It makes it more efficient when we have to if and when we have to write the page out again. It makes it more efficient because if the page hasn't changed, we don't actually do the write, so we save the I/O. We don't have to go through the whole process of locating another slot, things like that. So it adds some efficiency. However, as the real memory sizes get larger, could require more paging space than you're currently using. And in 6.3, we added early writes, so pages are written out earlier than they actually need to be. There's algorithms in the memory management changes that were made in 6.3 where the algorithms where it'll decide, okay, I know I'm going to have to write these out, or I'm probably going to have to write this group of pages out, so it'll write them out before it actually needs to reduce wait times, later on. So it added some efficiency. But again, between the early writes and the keep slot, it could increase how much page, because you're going to have more sets of pages that are in both places, right, in memory and on disk. So there's an age list. This is one of the factors, one of the things. The aging list is what is used to determine which pages get written out to disk, get taken out of memory and written to disk. Again, introduced in 6.3. So in 6.3, you could turn early writes off. The default is early writes on and keep slot on, or yes. Okay. In 6.3, we gave you the capability to turn early writes off, and now you can also in 6.4 turn keep slot off. So we wouldn't keep those pages, keep the data or keep the association for those pages. So that could give you, reduce your paging requirements. But again, you're going to have to wait to do that I/O depending on how much paging you're doing. But if your environment, you have a lot of memory and you're not doing a lot of paging, so the overcommit is low, you have enough memory and you're doing little or no, well, everybody does some paging, but little paging, you might want to consider disabling these and seeing if it makes any difference, okay? You might see, again, and it's you have to try it and see kind of before and after and take measurements and see if it's giving you any benefit or not. So something to try, something to think about, probably be useful for certain environments, but have more negative effect on other environments. Hyperpath, so now you can do paging I/O you can define alias volumes. If you have volumes that support hyperpath, you can define aliases and do paging I/O to aliases. So this allows you to have more than one I/O going on to the same device. So it gives you some efficiencies. that way. So we can do more things at once. So you can do more things at once. So you can have the alias pages. And when we say paging I/O, that doesn't mean just paging. Okay, so paging I/O, what we refer to as paging I/O is used for paging, spooling, things like checkpoint, warm start area. Anything we write to the system-owned volumes goes through what we're referring to here as paging I/O. So you can get more efficiency than just for paging. Let's say system volumes. Okay. So to decide if this is going to give you any benefit, you want to look and see if you have queuing on the paging volumes now. If you're doing queuing, you have weights on page writes. You can check these performance toolkit reports. And if that's impacting any of your virtual machines. If you're getting queuing and it's slowing down your virtual machines because it's waiting for paging I/O to complete, and you have hyperpav volumes, you might want to try enabling hyperpav for paging. It's dynamic, so you can set by command, set it on. You can enable it in your config file. Recommend you try it with the command first, see what the impacts are. If you don't have any surprises or you see you're either getting benefit or no negative benefit, no negative results, then you can enable it, permanently. So whenever you IPL, it'll just be enabled.
Is there an off option?
Yes, yes. Yes, so you can dynamically turn it on and off and see what the differences are. Or turn it on if things aren't going well, you can turn it back off. You don't have to IPL for that. And the way to know for sure is to take measurements, right? To check these reports before and after. Maybe if you're on 6.3, see how it's working on 6.3. Put 6.4 in, and see what the differences are with it on and off. And then you'll know if you're getting. That's the best way to, the most reliable way to see what kind of benefit you would get from this. If you're going to use this for paging I/O, we recommend having separate logical control units for your paging or your system volumes and for your mini disk volumes. We've supported hyperpav for mini disks for a while, so that's already there. If you mix them on the same logical control unit, you could have contention. If you do that for whatever reason, you have to, or that's just the way you have things set up. You can tune the alias, the share of aliases that are used on a given device for mini disk I/O and paging I/O. And these are the same concept. They're relative shares. So you can say, mini disk I/O is probably going to be a smaller share. You want to give the bulk of it probably to paging. Again, a command to fine-tune these dynamically, and a configuration file statement. And again, you can alter these. So again, you can change the shares and see what difference it makes dynamically before you put a permanent definition in your config file. The benefit of this, you can use fewer large paging volumes, larger volumes, and fewer of them in theory. But again, every environment's going to be different, so that's why it's important to take the measurements, check the data, and see what kind of benefit you're getting, or if you're getting a benefit. You don't want to turn this on and have it cause you, get no benefit or negative results, right? And even with this, recommend having at least as many paging volumes as you have logical processors for your system. So that's just kind of a bottom line minimum recommendation for number of paging volumes. You can also use high performance FICON for paging I/O. So you can enable that for the servers that support it. And similar to the hyperpav, you can set it on with command and then turn it on in the config file when you're content with the results. So again, you can do it, turn it on and off dynamically, see if it's giving you any benefit, and then turn it off or not, or set it permanently in the config file. Okay, dynamic SMT. Bill talked about this also. I guess he talked about everything I'm talking about. So dynamic SMT, we introduced SMT support. Well, the facility was introduced on the Z13 family. When the Z13 came out, and supported all of the processors since then. We introduced SMT with 6.4, but it required a config file change. Turning it on and off, to run multi-threaded or single-threaded required a config file change and an IPL. So if you wanted to experiment with it and see if you were getting benefit, it would require an IPL to enable it or an IPL to disable it. And that wasn't. It's not easy for you guys to IPL that many times, so it wasn't really helping. But architecture-wise, we have to do that. So now with dynamic SMT, we allow you to dynamically change the number of threads per core that are being used when SMT has been enabled. So you still have to enable SMT, but you can enable it for one thread per core, which we found gives you consistent, almost equivalent results of running with SMT disabled. So you can enable it. Let me do that again. Yep. I'm sorry. I was getting a little too worked up there. Coming back. All right, I'll be with you in about 40 charts. That's the projector. Okay. So you can enable it with one thread and then dynamically change the number of threads per core and check your results. Again, you go back and forth, take your measurements. Once it's on with multi-threading enabled, there's a set SMT command, type, and then you enable for 2 threads, and you can turn it back to 1 thread. This is a process. It doesn't, one second. There is a process. It doesn't change immediately. It starts immediately, but there's a process. There's some conciliation that has to be done and handshaking to get all of your cores set to the number of threads you want. Based on the work they're doing, they have threads with stuff running that has to finish. So it may take a few seconds for the transition to complete. So you can toggle back and forth. Okay, now you had a question.
So if you have your config file right now, it's saying multi-threading enabled, does it default to type all 1, or is there no default?
I'd actually have to check, but my guess is it's going to be 2 because that's what it was in 6.3. So for compatibility, we probably wouldn't have changed the default.
So if you want to make it dynamic, you have to put in type all at 1, so you can switch back and forth there, right?
Well, you can make it. You can define it type 2.
Right, but you have to have a type all something in there in order to switch back and forth. Right? Or no?
No, I'd have to look up the syntax, but
You're right. If it defaults to 2, you should be able to dynamically
go to 1. Right. Yes. Right. The other thing to be aware of here, very important, with SMT enabled, even if you're running 1 thread per core, you're limited to 32 cores. Okay. So if you enable SMT, the maximum number of cores you can have is 32. So if you need more than 32, 32 cores, this isn't going to work for you. So an example, just to illustrate, so when you have SMT 1 thread per core active, you've really enabled SMT. So you've told ZVM there are 2 threads in each core. I'm only using one of them. So if you do a query processor, you'll see the gap of 2. Essentially, the odd number processors, the second thread in each core, the second logical processor, is not active, so it won't show up. We change that to SMT2, then you see all the processors. So you see both logical processors in each core. Okay, so they are active. You're going to see they're just not visible, right? Not used. Yeah, Kurt. Does it slow it down? No. Well, what they found is when you have it set to 1, you basically get it's basically the same as having SMT disabled. I don't know if it's exactly the same, but it's close enough. Bill, do you have any? Okay. Thanks, Bill. Okay, live guest relocation. So with live guest relocation, when you're running an SSI, supports relocation domains. What's a relocation domain? It's a definition of members of a core that you want to be able to move, relocate guests to, regardless, and it resolves the architecture difference between those members. So if you have, say you have a cluster where you're running a 6.4 system and a 6.3 system, well, that domain by default will have only the capabilities, even if your guests are running on 6.4, they'll only have the capabilities that they had, that 6.3 provides. So you can move, so this way you relocate a guest to 6.4, it doesn't use something that it can't have if it goes back, or it can't relocate back to the 6.3 member. So you can define relocation domains for a lot of reasons. We can go into a lot more detail on that. But the key here is in 6.4, there are some of the new facilities, they'll make it a 6.4 system in a relocation domain. If you have a 6.4 and a 6.3 system, they'll be incompatible. So if you're running in a mixed cluster, enhanced stat, transaction execution facility, which are supported for guests in 6.4, you won't have them available to the guests if you have them both in the same relocation domain. So you can define domains differently. There's different ways you can define the domains to make it available, or maybe you put all the 6.4 members in one domain if you have multiples, and the 6.3 members in a separate one, so you can move the guests between those. So just something to be aware of. Not overly concerned about, but if you're in that environment and you're trying to use these facilities for your guests, you might run into some issues. Okay, and if you have questions about relocation domains and how to set them up, see me offline. I'm here all week, but we can talk more about that. So the guests won't see all the capabilities if you're in this mixed domain. You can define relocation domains with the set VM relocate command, and then you can mix and match which members, which capabilities are in a domain, and so the guests can be relocated freely among those. Environment variables. Bill mentioned the framework for metadata. You can define up to 1,000 environment variables. Something new. This helps with scripting, automating. What kind of environment is my system coming up in? For guests, what's available on the system? You can check environment variables maybe to see if some facility the guest needs, if it's either active or not, and maybe the guest doesn't want to come up and activate until that facility is available. You set them with the set variable, either command or config statement, so you can put them in your config file, or you can define them dynamically. There's a special variable at IPL time, you pass as an IPL parm, and then you can query the variables as well. This is an example showing the IPL var IPL parm. So this says, I'm coming up in my production environment. You might have one that says DR, so your system, your scripts that set up your system when you IPL, you may run different scripts or make different decisions in those scripts depending on this variable or other variables that you might have defined. So it gives you some flexibility. Be interesting to see what people do with it. Query CP service, Bill mentioned as well. You can look up what service is applied to your system, either PTFs, APARs, local mods, all of the above. If you're going to do all of the above, you probably want to capture it in a file instead of trying to read it as it scrolls by your console. So you might want to use a pipe for that. Put it in a file, then you have a record of all the service on your system. You can query for individual APARs or PTFs as well. This information is also kept in the monitor data. Just a straightforward, handy command. Okay. So shutdown of guests, so orderly shutdown. So for a while we've had signal support, for quite a while. Signal support allows a guest to enable itself to receive a signal when the system is going to shut down, or if somebody wants to shut the guest down. For Linux guests, to enable them for the so they'll enable, and then when a Linux guest gets the signal, it's equivalent of a Control-Alt-Delete. So you'd put this in your init tab file and tell it to shut down. You want to make sure you use H so it shuts down rather than restarts. Okay. So you want to make sure it shuts down. So this you're enabling your guests to accept a signal if the system is shut down. Then either in the config file or by command, you set the signal, the amount of time. So the signal shutdown time is 500. That says when I type the shutdown command on my VM console, we're going to send a signal to the guests and we're going to wait 500 seconds for them to shut down. Give them a chance to shut down orderly so they can come up and not lose data and things like that. Shutdown time is reserved for the VM. So if the LPAR gets deactivated, the VM system needs some time to shut down as well. And when you do this, the VM system will not shut down until either all of the guests that have been signaled have reported back that they have shut themselves down, or the time interval expires. So you can do an orderly shutdown of guests. So this has been there for a while, but the reason I'm talking about it is because in 6.4, we've made some enhancements. We've added a command, a query shutdown command, where a Class G guest, so any guest can get information about the shutdown time settings, whether the system is shutting down, how much time is left, okay? So can help you automate. You can build this into some automation maybe, see if shutdowns are going on. The guest can check, you log a guest on, and does it want to initialize? Does it want to boot up? If the system is shutting down, and then maybe it'll get cut off, and then maybe lose some information. So it helps you, be more sensible about or more structured about how your guests activate and shut down. So this shows, okay. Because we're